Alright, that concludes the fact that f is integrable. So now it remains to show that this equation holds. So we will prove, just in case we need to restart, let epsilon be bigger than 0. I'm going to prove, we will prove that the absolute value of f the integral, from a to c of f plus the integral of c to b of f minus the integral of a to b of f is less than epsilon, right? So if you subtract two numbers and you're less than epsilon for every positive epsilon, then they have to be the same thing. That's going to be our strategy. But we're going to think of it more like this. Or, let's see. We could say that negative epsilon is less than the integral from a to c of f plus the integral of c to b of f minus the integral of a to b of f, which is less than epsilon. Or, put another way, I can add this integral of a to b to both sides, and I get the integral of a to b of f minus epsilon has to be less than the integral from a to c of f plus the integral of c to b of f, which is less than the integral of a to b of f plus epsilon. And this is what I'm actually going to prove. I'm going to prove this pair of inequalities. So I have to prove two things. I have to prove that this inequality holds, that minus epsilon is less than the sum, and I have to prove that the sum is less than this thing plus epsilon. So let's do that. I'm going to split this into two different cases because I have two things to prove, and once I've done that, we will be done. So here we go. Well, what do I know? I'm going to start with the integral from a to b of f, and I know that for this partition up here, this p, so actually I don't want, we can use the same epsilon, right? For this particular p equal p1, p2, where p1 and p2 come from this epsilon over 2 business, that this is less than or equal to u of f of p. Why? Because this is an upper bound for the integral. I also know that u of f of p minus L of f of p is less than epsilon. So if I add this L to the other side, I get u of p is less than L plus epsilon. So this is less than L f of p plus epsilon, which just comes from this equation right here. Just rearranging that. Okay, well, what we saw before is that LF of P is equal to LF of P1 union P2, which equals the sum of these two things. So I'm just going to use that sum fact again, which is equal to LF of P1 plus LF of P2 plus epsilon. What that's doing is it's bringing back in the A to C and C to B back into play. In fact, I can say this very, very directly. This is less than or equal to, the integral. It's the lower bound for the integral from A to C, because P1 was defined to be A to C, partition for A to C, of f. That's less than or equal to the integral of C to B of f, and that I just bring down as epsilon. So therefore I get that's less than or equal to, that's less than, so I get less than here. So I get that integral from A to B of f is less than this thing, which I can rearrange by bringing the epsilon over to the other side, and I get that the integral from A to B of f minus epsilon is less than the integral from A to C of f plus the integral from C to B of f. And then I'm done with this half. This half I have right here. I'm done. Next screencast.